So yeah, on this Friday from 3:45 to 6:30 will be your final exam, and it's going to be on Moodle. It's going to be all on one page, so you're not going to have to click for the next question. The reason for that is to reduce the lag. So what you're going to basically do is you're going to answer one, scroll down, answer the next one. There will be a navigation bar at the top left, though, so you can see which ones you skipped and go to them from there. For now, we're just going to look at the old review. So let's just go back with some basic vocab. There we go. So the owners of a convenience store are concerned about the quality of service their customers receive. In order to study the level of satisfaction, they selected a sample of customers to inquire about their experience. One aspect of the study concerned the mean checkout time at the store. The owners hoped to find the mean checkout time for all customers was less than 5 minutes. So 40 customers were randomly selected, which resulted in the mean checkout time of 3.5 minutes. Identify the following: the population, the sample, the variable, the statistic, and the parameter. So what would the population be? What are we looking at? We're looking at all of the customers that the store has. So the population would be all of the store's customers. The sample would be the 40 customers that they selected. Now the variable, what are we actually looking at? Mean checkout time. That's what we're examining. So mean checkout time would be our variable. The statistic, or statistic is for the sample, S and S. Parameter is for the population. So the statistic is that sample mean of 3.5 minutes. The parameter is the population mean, and it said less than 5 minutes, so that would be the 5 minutes they're talking about there. Just like if you were writing your null and alternative hypotheses, you put this 5 minutes as mu, and you put this 3.5 as x bar. So the mu is the parameter, the x bar is the statistic. So this is basically just a vocab question. Make sure you're familiar with the terminology. All right, we're going to have to construct a stem plot. There was one of these on there for sure. Its format is slightly different, obviously. So let's look and see what we got for our stems and our leaves. So if I was doing this by hand, it would look something like this: stems over here, leaves over here. I have no single digits, so I'm not going to start with 0. I do have 1, so I'm going to put a 1 here, and it looks like the biggest I have is a 4. Yeah. 2, 3, 4. These do need to be in order, though. So the first thing you might want to do is put these in order. So if you have a TI calculator, that can easily do that for you. I don't think the Casio can order numbers for you. But you're just going to go through and let's just do it by hand. It looks like the smallest number is 15. I'll put a 15 there, cross it out. And obviously you'll be working on a computer, so if you make an error, you can just backspace and move it somewhere else. So it looks like 16 is next. Let's see, 18 maybe. And I think that's all my 10s. So let me look for my lowest 20s. I have 23 and I've got 2 of them. So I'm going to put a 3 and another 3, get rid of those. I have an 8, I have a 5. Okay, so 5 and then 8. All right, I think that's on my 10s and my 20s. So let me go to my 30s. Let's see, 37, 35, 233s. So I'm gonna use those 233s first, it looks like. And I think 35 was next. I've got 2 of those as well. And then it looks like 37 and 38. And then I've got 2 40s and a 42. Now, before I'm done with this, I'm going to count, make sure I have, at least have the right number of numbers. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So let's see, 1, 2, 3, 4, 5, 6, 7, 8 times 2 is 16. We're good. Okay, so that's how you construct a stem and leaf plot. Now, we're going to continue this problem. It gives us this important information here. So we could acquire this from the calculator if we typed all those in a list, but guess what? We don't need to because it gives it to us. So number 3 says calculate the mean. Well, you could type all those in your Casio and hit the X bar button, but you don't need to because it gives us the sum of X right here. And we know that the mean is the sum of X divided by the number of numbers. So actually, let me do this. So I'm going to do 481 over 16. And no, you won't be showing work on the test. It's just going to be your answers. They do have embedded questions and other things, so you will be have to answer each kind of part you would anyway. And of course, I don't have my calculator up. Sorry. No, I don't want you, Siri. Go away. Anytime now. So let me get my Casio. It should be popping up any minute now. And if not, well, we can just do this the whole old-fashioned way. 481 divided by 16. Oh, there it goes. 481. Oops, wrong load. 481 over 16 gives us 41 over 16. Imagine that, 30.0625. So if we look, we need to round properly. These are to the ones place. So I'm going to round to my 10th place, one place further. So I'm going to get 30.1. Each of the questions will have a little note on round properly, round to 3 decimal places, whatever they say. A lot of times it's just round properly. You have to know you go one place value further than your data. So that's it for the mean, sum of X over N. I have 3 Casios up, of course. Exit. Okay. Which of the following is not a measure of center? Well, the mode, median, and mean are your 3 measures of center. That means range ain't your measure of center, it's your measure of variation. So these 3, mean, median, and mode, are your measures of center. We talked about those a lot, especially when we started talking about the normal distribution. Remember, for the normal distribution, those are all right there in the middle at 0 or whatever the data value may be. So number 5 says calculate the standard deviation from this same problem. Now this one you might actually want to type in the calculator, but you don't have to. They do give us this information right here, so we can use that. It's entirely up to you if you want to type in the formula or you want to type each and every one of those stinking little numbers in the calculator and do it that way. So if we look, standard deviation shortcut formula is the one we want, and it's right here. So that's the square root. N was 16 times 15677 minus 481 squared over 16 times 15. And just type that in your calculator. And that gives us 9.007, et cetera, et cetera, et cetera. I'm going to go with 9.0. Yes, that 0.0 does mean something, sig figs and all. All right. So let's see. We got 6 through 8 working together. So I think I'll do this. And then this. I didn't call you Siri. Okay, so first thing I'm going to do whenever I see a chart like this is get my totals. Oh, bye, Taylor. Let me get all these totals up here. 14, 19, 13, 24. You might want to use a calculator if you don't mess up and get everything wrong because you added wrong. 47. Oh, look at that. 9 plus 7 plus 3 plus 4. 23. So that's the first thing I want to do is get all my totals. So 47 and 23, that's 70. So my the entire amount of people that were surveyed was 70. So if one American is selected at random, calculate the probability satisfied or west. So probability A plus probability B minus probability of A and B. Don't forget your basic condition rules. So that's probability of satisfied plus probability of west minus probability of satisfied and west. So let's see. Probability of satisfied is 47 out of that 70 plus west was 24 out of the 70 minus satisfied and West was 20. So 20 out of 70. So do the math, you get 51 out of 70. That's a 51, it's really hard to tell. Anyway, that's how you do that one. For number 7, it says if 2 Americans are selected at random without replacement, calculate the probability that both are from the South. So the probability the first one's from the South is 13 out of 70. And we didn't put them back. I don't know, maybe we threw them in a dungeon or something, who knows. But they're not there anymore. So now there's only 12 people from the South and 69 people total. So we do that in the calculator. 13 out of 70. Oops. 13 out of 70 times 12 out of 69. Dang it, I did begin. 12 out of 69. And that'll give us a nice simplified fraction of 26 over 805. So if you were in some other kind of calculator that didn't have nice, neat math type, you'd just do the same thing, 13 over 70 times 12 over 69. That'll give you that decimal, and then just convert that to a fraction, either an SD button or math, enter, enter on a TI, 26 over 805. You could also do 13 times 12 is that, and then 70 times 69 is that. So it's 156 over 4,830, and you just divide by the GCF of those. Okay, so if 1 American is selected at random, calculate the probability. Okay, so remember this line right here signifies given. So we're no longer looking at the entire 70 people from the population. We're looking only at satisfied. We're given that they're satisfied. So we're looking in this row only. So my bottom number is going to be 47. My top number, that's east. So 5 out of 47. So anytime you see this line here, that represents given. So that changes our population we're looking at. We're given they're satisfied, so we're looking at the satisfied population. Yeah. Going pretty fast. Guess we keep going. Oops, wrong button. So 9 and 10. Okay, these are going to take a minute. I'm going to do them both by hand and by calculators. So 3 ways. Okay, so it says approximately 60% of US adults have searched online for health information. Use this information to answer questions 9 and 10. If a random sample of 13 US adults is selected, calculate the probability that at least 11 of them have searched for health information. So let's think about this. What kind of distribution are we dealing with? Well, we have either they searched for health information or they didn't. And so that's talking about some sort of binomial condition there. It's a positive, a success, or a failure. So 60% would be our P, our probability of success. So let me get this out of the way for a minute. Let's write down our information. P is 60% or 0.6. So we know Q is the complement of that. Q is 1 minus 0.6, which is 0.4. I'll write it out. At least 11. So X is greater than or equal to 11. So if you have that chart handy that I gave you a long time ago, you know exactly how to use it in the calculator. If you don't, like I don't, you'll have to remember. Basically just rule of complements. But we can do it by hand anyway first. It's going to take a few minutes. So if X is greater than or equal to 11, that means X is 11, 12, or 13, because N is 13. So let's go look at our formula sheet. Where is that? I know, probably here we go. So this terrible, terrible formula here is we're going to have to do 3 times, unless you have a calculator that can do it for you, which you probably do. And it does say to calculate, not approximate it, so yeah. So here's what I'm going to do. I'm going to calculate the probability of 11. So basically, I'm going to plug 11 into all these little things right here. Then I'm going to calculate the probability of 12. Then I'm going to calculate the probability of 13. And I'm going to plug all that into the calculator, and I'm going to add it together. So let's get started. Again, you can do this on the calculator, so we'll get that afterwards. Maybe that a little bit. Okay, good enough. So we've got a numerator here, so I'm just going to put in parentheses. Really don't need to, since it is just a single term, but I do it anyway for safety. Okay, that's my numerator in parentheses. Divided by, I'm going to put my denominator in parentheses. And it was 13 minus, we got to do 11, 12, 13. So I'm going to do 11 first. Factorial. And again, you don't have to show your work on the test. So if your calculator can do it, you might want to do it that way, because it's going to take a minute. Don't forget to hit the times button. Multiplication. All right, that's my entire denominator. Notice I have my denominator closed into parentheses. That's this part. Times T is 0.6 raised to the, I thought I had math type off. That's okay. Actually, it's not okay. Let me change that. So you can see how it's going to look on your calculators. No. Yeah, I got to retype all that. Let me make sure the math type's off now. It is. So 13 factorial divided by 13 minus 11 factorial times 11 factorial times, okay, here's where we're at, 0.6 raised to the 11. This is what it's going to look like on your calculators if you do it this way. Times 0.4. Notice here we have more than one thing for our exponent, so you better put that in parentheses. 13 minus 11. Yeah, you could just write 2 if you wanted to. I'm going to write this thing down. Actually, I'm going to store it to A. So you hit the store button and then alpha, whatever letter you want. But probably 11.045. How many decimal places should we go? Let's go 4. 0.045 0.277. So I have 6 decimal places here, because at the end I'm going to round 4 decimal places. So if I keep 6 decimal places, I shouldn't get any rounding errors. Of course, I'm going to type in A, B, and C in the calculator. So now I'm going to hit second enter a couple times. I'm going to change all those 11s to 12. So now it's the same formula, except I put 12 everywhere that had an 11. That gets me that. I'll store that to B. 0.011319. Okay. And then probably 13. Again, just second enter a couple times. Now I'm going to change those 12s to 13. Which is why I did this on the TI and not the Casio, because it has a nice second enter button you can use. And we get 0.00. I'm going to store that to C. 0.001306. So if you don't have a store function, go ahead and go 2 decimal places further than what you're rounding to at the end, and you're generally going to be okay-ish. But I do have a store function, so now I'm just going to add A, B, and C. 0.0579. That was a lot of work. Luckily, your calculator does have a binomial distribution in it, both the Casio and the TI. I did forget what we do for at least. I'm going to figure that out real quick. Remember, we know we're going to do a CDF. So less than or equal to is our CDF of NP and X. And then if we do less than, that's CDF of NP X minus 1. Because it's binomial, that means our values are whole numbers only. So anything less than X is a whole digit less than X, a whole number less than X, X minus 1. So now I can figure out what greater than or equal to is, because it's the complement of less than. So I'm going to do 1 minus this right here. So I gave you this chart a while back. You took pictures of it and shared it in your chat. That's all good. If you don't remember though, just remember less than or equal to is normal CDF. From there, you can figure out whatever symbol you need. So I'm going to start with the TI. I've been working with it anyway. I need to go out of my way. Or not. Whatever. Clear that. So to get to your distributions on the TI, you're going to go to second, vars. Notice it has VISTR up there. And we need a binomial distribution. So we're going to scroll down till we find binom. Not a PDF, but a CDF. And try, if you have a TI-84, it's going to pop this up. I'll show you what it's going to look like on the 83 in just a second. So this is what you're going to see on the TI-83. It's NPX. So, so we need 1 minus NPX minus 1. That's why I put a 10 here. You could just put 11 minus 1. Doesn't matter at all. But make sure you go back, second, insert 1 minus that number. And this will give me, look at that, 0.0579. Same thing we got by hand. So that's how you do the binomial CDF on the calculator, the PI anyway. Casio's, you're up next. Move this over here so you can keep seeing it. Let's see where we're at. We're going to go to mode. Where's distributions at? Down. Number 3. Binomial, not a PDF, but a CDF. So all I did was I hit down arrow again. Binom CD. And we don't have a list of numbers. We have some variables. That's what we're going to do, number 2. Now, this order is different. It's not MPX. It's, I forgot, but it tells you right here what's X. Don't forget, we have to do X minus 1 here. So instead of 11, I'm going to type in 10. What's N? 13. What's P? 0.6. This is going to give me this part right here. I still need to do 1 minus that answer. So go back to mode 1. There you basic calculations. Do 1 minus your answer. There we go, 0.0579. Ta-da. Okay. So that I'd highly advise just using the calculators. They're a lot more convenient than doing this by hand. And you're very likely to make a mistake in typing this in the calculator because of all the parentheses you will need. So just remember how to fix which symbol you have. I guess since we have these 4, I'll go ahead and do the other 3. Did I say 4? I did. Wow. Well, greater than is the complement of this, so it's just 1 minus CDF of NPX. That way, if anybody's watching, they can see all 6 different symbols and what to type in the calculator. The other 2 are equal to and not equal to. Now, those are not cumulative distribution functions, but point. Those are going to be PDFs. NPX. So you could have any one of these on your final. I don't know what you're going to have. So make sure you know how to type in the calculator. And if you guessed it, to do a not equal to, you do 1 minus the PDF. And there we go. All right. So that was, I forgot already what question, number 9. Look at number 10, see what it says. Might call it a day after that. No, where was that information? There it is. Let's see, calculate the mean and variance. Oh, I don't do that. The number of U.S. adults who have searched for the online health information for Central City. Oh, okay. So this is a lot easier, like totally way easier. Grab your formula sheet. We need the mean and the variance. Oh, look, there it is. It even says mean and variance of binomial. Easy stuff here. So the mean, right here, n times p. Let me write down n is 50. P is 60% or 0.6. So that makes Q 0.4, same way it was last time. So 50 times 0.6, you need a calculator if you want to. $30. 30. The variance, it says? Yes, the variance. Now, do note that this could ask for standard deviation. Standard deviation is the square root of that. But this question did say variance, so we're going to use the variance formula. So that's going to be what, 12? So sigma squared 50 times 0.6 times 0.4, yeah, 12. That's it for that problem. Couldn't get much easier than that. Let me just take a look, see what we have left. We might call it a day there. There's 23 of them. I guess we should at least do half of them. Find the value. We'll do 12, or we'll do 13 because that's 12 and 13. That way we can be halfway done, because those last two are hypothesis tests. Find the value. Okay. And again, I'll do these by hand with Casio and with TI. So we've got the, it says find the Z value for this sketch, basically. So we know the area to the right is 0.79. Okay. So if we're looking on the chart, that's giving us the area to the left. So to get the area to the left, we know the whole area is 1, because that is the probability. The highest probability you can have is 1. So I do 1 minus 0.7900. That's going to give me 0.2100. And that's going to be my area to my left. So that's going to be this shaded region here in yellow. So if we're looking it up on the chart, we always need to have the area to the left. If you have the area to the right, they're complements. So we're going to look up 0.2100 on the chart, and we can see it's to the left of the mean. So we're going to use the negative z-scores. Negative z-scores. And I'm going to look up in here until I find 0.21. Yeah, 0.21. Okay, here's 15, 18, 20, 20. Okay, it's somewhere between these two. Let's see, 2148, 2119, or 2090. Which one of these is closer? This is 19 units away. This is 10 units away. That's closer. So negative 0.81. Z is negative 0.81. Just find whatever value on this in the area is closest to your area in the chart. So this is 19 units away, this is 10 units away. That makes this one closer. So we're going to use the negative 0.81. So in the calculators, I'll start with the Casio. For some reason, I just pulled up first. Doesn't matter. We have the area, so we need to do an inverse normal. The area to the left, it's always about the area to the left, so 0.21. And we get negative 0.806, et cetera, et cetera, et cetera. If we round it to 2 decimal places, it's negative 0.81, same thing. So yeah, notice I did not change. My mean is 1, or wow, my standard deviation is 1, my mean is 0. That's the standard normal distribution. TIs, again, distributions are second bars here. Inverse norms number 3, 0.21, leave those alone. And if you wanted to, you could actually just put inverse normal 0.21 and it will assume it's standard normal. So again, negative 0.81. That's how we do that. fifth time's charm here. There we go. All right, so we'll do these two and we'll call it a day. All right, the serum cholesterol levels for men aged 18 to 24 are normally distributed with a mean of that and a standard deviation of that. The units for measuring who cares use this information to answer questions 12 and 13. So let's look at 12. So first thing I'm going to do is write down my information. It's normally distributed. Mean is 178.1. We're not talking about a sample, we're talking about the population here. Standard deviation is 40.7. And here it says calculate the probability that a serum cholesterol level is lower than 200. So I'll call that X is less than 200. So it's been a while, but yeah, we can do this by hand first. Okay, what kind of distribution do we have? A normally distributed one, so it's a normal distribution. We're looking up here. Oh, hey, look, chapter 6, normal distribution. So it gives us this to convert our scores here. I guess I use that one. So we have to convert these to a standard score so we can look them all on the chart. Look them up on the chart. So my X is 200 minus 178.1 over 40.7. Mode 1. And I get 0.54. I'm only going to go to 2 decimal places because that's on the chart, right? So 0.54. And I want less than 200. So that's the area to the left of that, right? So if we look on the chart, I'm looking for 0.54. 0.54 is right here. So there we go. The area to the left side is 0.67. And it, again, the area under the normal distribution curve is its probability. So my area, my probability, same thing, is 0.67. Now, if you're doing this on a Casio or a TI, you just go to your distributions, the normal CDF distribution. Your lower bound, it's less than 200, so negative infinity, 1 times 10 to the 99. That works. Your upper bound, 200. Your standard deviation, 40.7. Move that over so you can see where I'm getting these from. Your mean, 178.1. I do expect to get something slightly different. 70.47. Okay. So there's a lot of rounding going on if you're using the charts. So you are going to get a slightly different answer than if you were to just use some technology. So the probability is 0.7047. We use a TI. Again, go to your distributions, normal CDF. Lower bound, negative infinity. Upper bound is 200. Mean of 178.1. And a standard deviation of 40.7. And we get the same thing as on the Casio. This is what you would see on your calculator. It's lower bound, upper bound, mean, standard deviation in that order whenever you're typing this in, because it won't tell you if you have a TI-83. So lower bound, upper bound, mean, standard deviation. And that's it. So if we use the charts, we get 0.67. If we use technology, we get 0.7047. So I guess we can go 4 decimal places, 6700. All right. And the reason so far of a difference is because we had to round this 0.54 a lot. Let's look at number 13 though. Same process, except this time we have 36 men. So we're going to apply the central limit theorem. Around here somewhere. There it is. The central limit theorem basically says you take sigma and divide it by square root of n. That's the only difference. So instead of this, I have to take this and divide it by square root of n. That's the only difference whenever you have some sample size here. Which if you think about it, if we have 1 man, the square root of 1 is 1, so it could use the same formula. All right. So I already wrote down that information. Let me copy paste it. Sure. I'll get you in a second. There we go. There's my information. I guess I can take the problem back now. And this is what we're looking at. All right. So we also have n is 36. And instead of being less than 200, we're greater than 200, what we're looking at. Calculate the probability of the mean cholesterol level is higher than 200. So let's go ahead and calculate this z-score here. 200 minus, we already have this on the other page, but I'll do it again. So the difference comes right here, divided by square root of 36. So $200 minus 178.1. And if you're doing this on a non-Casio or something that doesn't have math type, make sure you put your numerator in parentheses. Yeah, I'll go ahead and do it for you. For you TI instead. The numerator in parentheses. Divided by denominator in parentheses. Now notice I close my square root for my parentheses. I close my parentheses for my square root, but I also need to close my parentheses for my denominator. So I get 3.2285 there. So 3.23. If we didn't type in that central limit theorem, the square root of 36 right there, we'd have gotten that 0.54 again. All right, so 3.23 this time. So that's a huge difference. Let's see what that's going to give us. I'm going to look up 3.23 on the chart. Three 3.20123. Yep. 0.9994. But that's the area to the left of 200. We want greater than 200. So what we have to do is apply the rule of complements and do 1 minus that number. So the probability is actually 0.0006. And if we use the technology, we should get something similar. Second bars, normal CDF. Lower bound this time is 200. Upper bound, I'm going to do E99 for infinity. Mean doesn't change. Standard deviation does change. Do not forget to change it. Divided by square root of 36, or you could just put 6. And again, that's what it's going to look like in your calculator. Lower bound, upper bound, mean, standard deviation. Don't forget to divide by square root of your sample size. And it gives it to you in scientific notation. Times 10 to the negative 4. That means we have to move this decimal back 4 spots. That's going to make 3 zeros in front of a 6, just like we have here. Casio, same thing. Go to your distributions, normal CDF, lower bound of 200, upper bound of infinity, 1 times 10 to the 99. So 1 times 10 to the 99, that's 1 followed by 99 zeros. That's what we use as infinity. It's pretty much the biggest number these calculators can handle. Sigma, that's 40.7 divided by the square root of 36. And then mean was 178.1. And we get the same exact thing we got here. Well, actually slightly different. They store different numbers of decimals. But rounding to 4 decimal places, we get the same exact thing. 0.0006. So yeah, I think that's good for today. We did about half of the review. Hopefully tomorrow I'll have the digital version on Moodle for you to look at. If not, we'll just finish off this review, and you know what, we might actually finish this review off anyway. Pretty much the same kind of stuff. The other one's basically formatting that you want to look at. Were there any questions? All right, if there's no questions, guys, I'll see you tomorrow.